The razorback sucker is a species of fish that was historically quite common in both upper and lower Colorado River basins. As one of the largest suckers in North America, the adult razorback can reach lengths of 2 to 3 feet and weigh up to 10 pounds. Also, the razorback can live up to 50 years. This unique fish can be recognized by a distinctive hump on its back and by its large head. Generally, razorbacks are found in deep, clear waters. However, during breeding season, they can be found in backwater areas or areas of slow current. This species of sucker feeds on zooplankton and other similar small organisms. Specific locations where they are found today include segments of the Green, Colorado, Yampa, White, and Gunnison rivers, as well as a small number in lakes and ponds including Lake Powell. The razorback sucker is believed to have evolved around 4 million years ago in the Colorado River Basin, which is now one of the only places on Earth that the fish can be found. In fact, it is estimated that there are now as few as 500 adults in the upper Colorado River Basin. As a result, the razorback has been protected under Utah state law since 1973 and was added onto the federal endangered species list in 1991. But many are asking, why has a species that was once so abundant become so close to extinction? And as may be expected, there is not a single answer to this difficult question. Some of the reasons for the decline of the razorback population include harvesting, alterations to water flow and levels, loss of habitat, blockage of migration routes, changes in water temperature, introduction of non-native species, and finally pollution. Razorback suckers were a thriving species during the late 1800s and early 1900s, so much so that they were hunted and harvested commercially. This harvesting dropped the razorback population significantly enough that they were less able to cope with the challenges that soon faced them. Beginning in the early 20th century, much of the razorback's natural habitat was altered, if not eliminated, by human development such as dams, reservoirs, and irrigation withdrawals. In fact, there are more than 10 dams along the lower Colorado River and its main tributaries. Because the razorbacks breed best in shallow, slow-moving water, these man-made structures have affected these fish in a number of negative ways. First of all, the suckers mate at temperatures between 10.5 and 21 degrees Celsius. However, these temperatures are no longer guaranteed during mating season. This is partially due to the presence of dams and reservoirs, and is further precipitated by certain dams that systematically control water flow and temperature in an attempt to make the rivers more hospitable to sportsmen and recreation. In addition to changes in temperature, the water levels have been raised in some areas and lowered in others. This has fragmented populations of the suckers, eliminated former mating areas, and blocked off migration routes. Another problem facing the razorback suckers has been the introduction of non-native species. There are currently 40 new introduced species in the Colorado River alone. The suckers are affected negatively by these new species both as a result of competition and predation. For example, in Lake Mojave, eggs are preyed upon by carp, and juveniles are regularly eaten by other fish species such as the sunfish. Therefore, despite the fact that spawning is occurring, very few of the new razorbacks ever reach adulthood. Over the past 30 years, scientists have been focusing on the impact that water contamination may be having on the razorbacks and other native fish species. In particular, studies have been conducted investigating the presence and impact of the element selenium. In 1986, sediment and biota from the Green River Basin showed the presence of selenium at levels that could be harmful to fish, and that this contamination entered the water from industrial irrigation systems. Adult razorbacks from the Green River have shown an accumulation of selenium in their systems, which is likely getting passed on to their eggs. This buildup may be a factor in why so few razorback suckers are reaching maturity. As previously mentioned, the razorback sucker was included on the U.S. Fish and Wildlife Endangered Species List in 1991, and as a result there have been efforts to rebuild the sucker population. Some of the strategies that have been used include managing the non-native fish population, habitat development, and creation of new migration routes. Government agencies have also used a practice known as native fish stocking, which in this case entails placing large numbers of the razorback sucker into locations where they once thrived, but are now being outnumbered and outcompeted by other fish species. As for now, there has been little improvement to the razorback population. However, if a single cause for the population drop-off can be determined, it might be the first step in the recovery of this species.